A particle is moving so that r vector is given to be this, where w is the constant, and we need to show that the velocity of the particle is perpendicular to r vector. Perpendicular to r vector means we need to get the dot product of this r vector with the velocity. What is velocity? It is dr by dt, that is the derivative of position vector with respect to time. We need to show that the dot product of r vector and the velocity should be equal to 0. This is the condition when these two are perpendicular. Then, to show that the acceleration is directed towards the origin. Directed towards the origin. If the acceleration comes out to be negative, if it is coming out to be in negative, which means this acceleration is a vector opposite to the direction of r vector. From the origin, r vector is along this direction. Acceleration is in negative. Negative means it is opposite to the direction of position vector. Acceleration is opposite to the direction of the position vector, which means it is directed towards the origin, right? And it is having the magnitude proportional to the distance from the origin. Magnitude means we need to find the mod of a vector. Then third part, we need to show that this cross product is a constant vector. So first we need to show that the velocity is perpendicular to the position vector. What is the position vector given to us? It is cos wt I vector plus sin wt j vector. This is your position vector where w is constant. And what is velocity? It is the derivative of r vector with respect to time. That is minus sin wt into w I vector plus cos wt into w j vector. We can also write this as minus w sin wt plus w cos wt j vector. So this is your velocity. To show that this is perpendicular to r vector, the velocity is perpendicular to r vector, we need to show that the dot product of v with r vector is 0. This we need to show. So let's take the dot product now. The dot product of v vector with r vector. Writing this complete v vector and its dot product with r vector. We know that the dot product of I with I is 1. So taking the dot product of minus w sin wt with I vector with cos wt I vector. So that gives minus w sin wt into cos wt. That's it. And now taking the dot product of these two. So this is plus w. I'm writing first sin wt and multiplied with cos wt. That's it. J dot j is 1. So these two cancelled out. These are opposite to each other and we are getting this dot product to be equal to 0. Hence, the velocity is perpendicular to the position vector. Now for the acceleration. The acceleration is directed towards the origin. This we need to show. This is the origin. If we need to show that acceleration is directed towards the origin, that means we need to get the acceleration in negative. Okay, what is acceleration? It is derivative of velocity with respect to time, or the double derivative of r vector with respect to time, whatever way you want to find. Okay, I'm derivating the velocity. What is the velocity? We have found velocity to be this, that is minus w sin wt I plus w cos wt j. Derivating this with respect to time, it is minus w, this will be cos wt and the square I vector, and minus w sin wt and the square j vector. and this is coming out to be in negative if I take minus outside. And we have cos wt I vector plus sin wt j vector, and this is nothing but your position vector. This is nothing but your given position vector. So from here we say that acceleration is opposite to this position vector, which means it is directed towards the origin. So since acceleration is a vector opposite to the direction of r vector, the position vector, that is, the acceleration is directed towards the origin. And now finding the magnitude of acceleration, that is the mod of a vector. What is the acceleration? We have found this to be this minus w square r vector, minus w square r vector. So that is equal to w square r vector. So from this equation you can say that it is directly proportional to r vector, where w is the constant. So which means this acceleration is directly proportional to r vector, right? That is the distance of the particle from the origin. So hence acceleration is proportional to r vector. That is the distance of the particle from the origin. This is your particle, this is the origin, this is the distance of the particle from the origin. Third, to find the cross product of these two, the value should be the constant value, right? Okay. What is r vector? It is cos wt I vector plus sin wt j vector, taking its cross product with dr by dt, that is velocity, this one. Now cross product of I vector with I vector is always 0. The cross product of the same vectors is always equal to 0. Please note this. And the cross product of I vector with j vector when taking in cyclic order, like if I'm having I, j, k, when taking the cross product of I with j, write here k vector. But when taking in the reverse way, that is j cross I, so you have to write minus k vector. Similarly for the other cases. Okay. So I cross I is 0. Then taking the cross product of I with j, that is k vector, and also multiplying these two, we have w cos square wt k vector, right? And plus cross product of j vector with I vector in the reverse way. In the reverse way we take negative k, right? So it is negative k, and also when multiplying these two we have negative sign over here, and because I'm also having the negative sign over here, the sign becomes positive, and when multiplying these two we get w sin square wt k vector. I hope it is very clear. And now taking the cross product of j with j, that is 0. So there is no need to write this. So we can take this w outside, and also k vector. We have cos square wt plus sin square wt. I am writing this k vector outside. And this is w. This is nothing but 1 k vector, that is equal to w k vector. So the cross product of r and v is coming out to be wk, where w is constant. Where w is constant. So hence we have shown that this cross product is a constant vector. K vector is with W, so we have this to be as your constant vector. Alright, thank you. Stay blessed.